Thank you very much for coming to this session, which is all about getting data in and out of Notch. How many people were in my session yesterday on 16K, breaking the 16K barrier? Okay, so at the beginning of that talk, I said it's a really stupid idea to do totally live demos when you do a demo. And I was proved in the demo by something not going quite as I planned during it. So today I'm going to do exactly the same thing and do a whole set of live demos because, again, there's no point in me just putting slideshows for this. You actually really need to see this in action. So bear with me if I have little hiccups. I'm sure you'll be gracious. Right, so a couple of ground rules. I'm going to be going fast and slow at points in this. I'm going to slow down on the new stuff and on the content where people have had challenges in the past and go fast through a whole bunch of things that I think most people know about. Bit of assumed knowledge. You know what Notch Builder is. You know what a Notch block is. You know what Notch Standalone is. You know what an exposed property is. And you've used modifiers before within Notch, because I'm not going to be covering off what any of those things are. Right, so we never want Notch to be an island, and we want Notch being a real-time tool to be able to accept data from lots of different places. But how we accept that data differs upon the type of protocol and the type of data people are trying to put in. So there are lots of industry protocols which are used very widely. So in the data space, we've got web APIs, JSON format, CSV. In live, we have OSC, MIDI, ArtNet, DMX. But then within each of the industry niches, which so many of you represent here, there are very specific interfaces. So like stage automation systems, PLC systems, and the many wild and wonderful devices that you guys just come up with and message us about on support, which we've never heard of. So we approach these different types of interfaces in two ways. With industry interfaces, we're all about connecting standards in, and I'll talk a little bit more about that in the future. And when you're running Notch Standalone, you basically get access to our standard interfaces that we deem are appropriate. However, when you run in a media server, the media servers instantly give you access to a whole range more protocols. And this is really important because there's a lot of interfaces that we are just simply not going to implement because we believe that our partners in the media servers do a much better job of doing it. And they all are, all the media servers and platforms have spent years and years working in these specific industries, building up these libraries of interfaces. So in these settings, we run as a Notch block within the media server. The media server receives that specific information in, and then using the API that sits between the Notch block and the media server, which is seamless to you, you can get that data into the media server. Yeah. So there's lots of times people email us saying, can you please implement this? And we turn back around to people and say, there's a media server that does that and runs Notch within it, and you should probably go and use that. There's a second reason why we really lean on our partners and media servers, and a lot of that is to do with management interfaces. So when you're running in Notch Standalone, as you've seen, you double-click and you get a full screen of Notch Standalone. There's no UI, there's no management interface. The media servers have spent years and years building management interfaces that you can have running up in front of you whilst your content is going away and running, and we're not building those things. Yeah. So if you have a PLC system or stage automation or black tracks coming in, you know, there's lots of different screens and dialogues that you need to be able to go and manage that that we're just simply not going to do. So lean on the media servers for those specific niches. We do have a nuclear option for integration of protocols. So there are a select number of partners, so obviously the media server partners, but we have a couple of very experienced development partners who are, we've authorized to run Notch blocks in their bespoke apps. So those In those scenarios, there's a contract that gets signed, we release the SDK to them, and they are able to use the general purpose interface back and forth with the notch block to bring in those specific bespoke protocols that no one else is really going to go away and handle. So you can talk to us about that, and there's a bit of a qualification process before we hand it out, but you're more than welcome to talk to us about it. Right, so I've talked about these two different sets of standards, the standards that fit within these niches and the media service look after, but what about the standards that we're adopting, the ones that we're allowing directly into Notch? Well, our philosophy on this is fairly straightforward. Basically, we're looking for complementing skill sets within our Notch user base. So let me explain that a little bit more. A lot of our users live in the agency world. So they are working, maybe producing corporate events, or they are building an interactive experience. And when you look at these types of agencies, they often have a design team, which are obviously using Notch. But quite often they have a web team as well. And web skills are just everywhere. You know, web APIs, HTTPS calls. If you don't have those skills in-house, you can get a freelancer in any city of the world at pretty much the drop of a hat. So we've really focused recently around web APIs and building up the functionality around that, because it is a good way of getting data into Notch. Likewise, as most of you will know, we have a JavaScript scripting engine, the VA engine within Notch. And again, if you've got a front-end developer or a Node.js developer, they are able to come into the Notch environment and start scripting for it. So we don't want design teams having to sit there writing code. We want them to be able to find someone very quickly who can go write code for them. They might write the code themselves, that's fine, but we just want skills on tap. Likewise, we have the same approach with the AV production industry. You often have a content team, and then you've got a whole technical production department at the same time. And they are all day using ArtNet, OSC, MIDI, and media servers. And so it makes sense for us to be able to support some of those protocols, and then the media servers pick up the rest of those protocols. So again, this kind of complementing skills idea. So for the rest of the session, I'm going to be doing a bit of an interface world tour. We're going to run through some of the AV interfaces that we support, and then look at some of the data ones, and I'll be revealing 2 new features that we'll be releasing in 0.922 at the end around data. Okay, so the AV protocols. OSC. The Swiss Army knife protocol, or as I like to call it, the hijacked protocol, because it gets used and abused in such horrible ways. But the strengths of it are it's incredibly widely adopted, especially if you come from an audio world. So you've got Ableton, Maximum SP, Resolume, QLab, so many of these packages all support OSC. And it's a fairly understandable protocol to get your head around. You can get we see a lot of people using like Lemur and Touch OSC to build interfaces which can control Notch. If you saw Brett's talk yesterday, he was using OSC to be able to go and trigger audio in other packages. The other advantage of OSC is there is just a ridiculous number of device to OSC programs out there. So if you were at the main stage a second ago, you would have seen Lewis Carl White, and he had his little leap motion on the podium, and he's turning that into OSC using an off-the-shelf package and then pumping that into Notch. It's very flexible as a protocol, and it's broadcastable, so you can have a single source and broadcast it out to many different PCs. I'm just going to run through the protocol because we hit this on support all the time, so I just want to explain OSC a little bit more. So OSC is basically a set of messages that you send from your source device to your end device, and those messages are made up of 2 parts: the address and the payload. Yeah, and sometimes people get a little bit confused and start putting their payload into their address. Yeah, so let's talk about this a little bit more. The address is a string which has forward slashes in it to kind of break down the granularity of where you want the command to go. When you're in Notch, you just match that address, you just enter that address, and it will listen out for that address, for the messages which hold that address. But then you have a payload, And the payload is made up of lots of different data types, and you can have as many as you want, and you can mix and match what those data types are as well. So the 3 types of payload that we support are floats, integers, and strings. Yeah. There are about another 6 or 7, like globs, blobs, and all sorts of things. We don't support those. These are the 3 that we support. So the most common problem I see when we get support requests around OSC is that people are putting their payloads into the address line when they're sending out of their source application. Yeah. So they'll write percussion, drum, snare, space 1.0, and they'll send that all in the address, but it should be going in the payload. I can't tell you how to put it in the payload in your source application, but just find out and do it, and don't email us again. Okay, so what can you do with OSC? In Notch, you can listen out for these messages coming in, and you can pump them into an OSC modifier, so that will give you numeric values. You can receive OSC text strings, so you can put those into text modules. And you can also send out OSC, numeric OSC, out of Notch as well. Lastly, you can also control playback in standalone, and this type of transport control allows you to change layers when you're in standalone. It allows you to move the playheads to play and pause. So that's used quite a lot as well, especially from control surfaces for controlling standalone. When you're building things in Builder, there is a connection monitor. I don't know if you've actually ever seen this, but if you go into View and click Connection Monitor, it monitors all the different types of data sources which are coming into Notch. And on there, you can see the OSC, the amount of OSC bytes you're receiving on your given OSC port, but you can also see the addresses which are hitting into Notch as well. And this is really useful for debugging. When the guy on the other machine is saying, I'm sending you this, you're able to see it without having to go and configure modifiers to be able to listen for it. Yep. So Connection Monitor is definitely your friend. There's a couple of things you need to consider when using OSC, and the main one is port reuse. So OSC uses a protocol called UDP, and when you set up your standalone or block, you say, I want to listen on this particular port for these OSC messages. The issue is that you can't have multiple applications all listening for OSC on that port. So if you've got Builder and standalone open on the same machine, then the first machine will take that OSC port. Yeah. If you've got Builder and your media server running on the same machine, and your block is listening on that port, then if Builder started first, you're not going to be able to hear it in the media server. Yeah. So you need to just be careful when you're starting up Notch or your media server that you haven't got other things listening at the same time. And this, to be honest, is why we encourage people to use the OSC interfaces in your media server, because the media server can act as like the conduit to pass all the data to all of your blocks. Does that make sense? So you listen on your media server, set up the addresses on it, and then pipe it through as exposed properties into your block. Yep. Okay, so I'm just going to do a very quick OSC demo. And I'm just going to fire up. So this time of year, I start dreaming about the Mediterranean. My wife is persistently asking me, can we go on holiday now? Because it's so dark and grim. She's from New Zealand, and she hates the winter here. So to keep us all happy, I asked Will to create an idyllic scene for us, which is a boat in the Med. A boat I'll never be able to afford, but one that looks pretty nonetheless. So we'll just fire this up now. Here we go. Here's my boat. All right. I'm just going to swing my camera around to here. Right. So in this setup, what I've done is this navigation compass down here, I've attached to a bunch of OSC parameters. So here's my OSC modifier that is listening for the address of compass heading. Yeah. And I'm going to fire up, I've got a little Python script that's going to send in OSC. Most of the time you would not be receiving Python you would not be receiving OSC from a Python script, you'd be receiving it another way. But just for the purposes of this demo, it makes it a little bit easier. Okay, and you can see down here at the bottom, the OSC data that I'm sending into Notch. I'm sending a heading, and I'm sending speed. And you can see to the right of it, the payload that I'm sending into those addresses. Yep. Okay, if I come back into Notch now, you will see this data starting to change over time as I've sent it in from OSC. Now, whenever you are sending in a network protocol into Notch, you should always use a smooth envelope after you've received that raw data. So in this case, I'm sending the data in for OSC at like 1 frame per second, yeah? And if I took away the smooth envelope modifier, you'd see these big jumps taking place and go, which just looks awful. So even if you've got a great network connection and say, my OSC is amazing, and then you get to site and then it's like running over Wi-Fi and you're dropping packets left, right, and center, it just always makes sense to put the smooth envelope on, even if you've got a really high level of attack on it. So here's our OSC modifier bringing in the value, so taking that payload on that heading. Now, if there were multiple payloads in that OSC message, I would be able to change through the index here. So 0 being the first one, 1 being the next one, 3, and moving your way up. So you can handle multiple items in the payload. Right, so there you can see the smooth value, just moving my graphic around. OSC text string, as it does what it says on the tin. You give it the address, and it just gives you the text, and I'm then punching that into a text node. All right, moving on, ArtNet. So if you've ever worked with any type of lighting, you'll know what ArtNet is. ArtNet is DMX over IP. DMX has got to be one of the oldest protocols around, but it is the standard for lighting desks. The strengths of it are every lighting desk in the world supports DMX, and most of them support ArtNet. Again, ArtNet is broadcastable over a network, so you can have multiple standalones or media servers all listening to ArtNet at the same time. ArtNet, predominantly, its use with Notch is through a media server. The media servers all listen to ArtNet, and then you generally pump that down as an exposed property into a Notch block. However, there are occasions where people do run it directly into Notch. Either which way, ArtNet is all about fixtures. So the simple setup is, most of you will know this, we have a desk. It wants to talk to a lighting fixture, and you have a personality table that tells you what all the channel mappings are for the different types of controls for that fixture. So pan and tilt will be on separate channels. And when you get to your lighting fixture, you get a table with it that you can program into your lighting desk, or your lighting desk might have a library of these personalities for these different types of fixtures. The whole object with Notch and the Notch block is that really Notch should just be another fixture, yeah, that you're building a table for and then handing to your lighting desk programmer and saying, right, these are the ways I want you to control the block on these various different channels. So to do that, we have a UI interface that allows you to do channel assignments. So what you firstly do, these are slightly gone out of order. You expose, when you're within Notch, you can expose any given value just by clicking the exposed property value here. And once it's exposed, it will turn up in the second exposed property tab here. At the top of this dialog are all the exposed properties that you've not assigned to a DMX channel. And to assign them to a DMX channel, you literally just drag them in. Yep. And you can lay them out and build your channel assignments. If you've chosen a value to be exposed and you want greater precision, you can just turn on DMX 16-bit, and it will take up 2 slots in here. Yeah. So this Channel assignment works whether you are working with a media server or whether you're working with standalone. When you're working within a media server, what we do when we export the block is we present the table to the media server and say, when you are exposing this block out to the lighting desk, this is the channel map you should use. And that process is called DMX hinting. And I'd say about 50% of our media server partners support this at the moment, and I would hope by the end of the year that all of them will. But it basically allows the media server to build that fixture personality for you. If you're running in standalone, then the channel map that you create is just being directly mapped to when you start up standalone. A couple of useful things. There is an ArtNet monitor in Notch, so just go to View, ArtNet, and you will be able to see the data arriving and the values which are coming in on each of the channels, and you can change which ones you're seeing in the text fields above. Right. So as I said, ArtNet will be going directly in when you're running in Notch standalone. If you need to enable that, you go into your project settings, ArtNet OSC, and click ArtNet Enabled. You set the network device that you need to connect to, and you're set. When you start the standalone, you can add a parameter called debug1, and that will start showing you ArtNet data in an overlay in the standalone. And you can also offset the personality that you've created in the standalone by just going ArtNet offset and putting in the number of channels you want to offset by. Okay? All right, that's ArtNet. MIDI. MIDI is used a lot with control surfaces and other sound applications. The great advantage of it is it's ridiculously cheap. You can pick up a control surface for $20. The weaknesses are, especially in Windows, my word, it's finicky. It's really hard these days. And when Windows removed their MIDI mapper just a couple of years ago, it got even worse. And there's no broadcastability. It's just like one MIDI device to one machine. There are workarounds and packages you can get online to get around that, but it's not that pleasant, really. So what can you do in Notch with MIDI? Well, you can get a MIDI modifier to bring in a control channel from MIDI. So not key presses, but control channels, and pull those values into Notch. And you can generate a texture from MIDI notes, which are kind of lines that go across, and then you can use them to alter meshes. When Windows removed their MIDI mapper, we had to build our own. So if you go into audio and MIDI devices, you'll find that you can set up the device numbers into slots. You click those, choose your MIDI device, and then when you're addressing in the MIDI modifier node, which device you want to go to, you're actually using those numbers that are mapped out in that table. Right, as I mentioned, media servers provide far more in the AV space, and you should talk to them about what they support themselves. Okay, I'm going to move on to data protocols now. In 0.9.21, we introduced CSV tables, and these are useful in a couple of different ways. I'm going to skip across to this project here. CSV tables are a resource that you can bring in. We say CSV tables, but you can actually bring in text tables as well, and you can set your own custom column delimiter. So if it's a semicolon, you can just choose that instead. But everyone refers to them as CSV, so we've called them that name. There are multiple ways to use that resource once it's in. If you want to start spawning geometry from it, we have a CSV transform array. And you can see here that I have a shape attached to the transform array. And what it is doing for every element in the row, it is creating a new object. So it's cloning that object on the way through. So you can choose flat list, but most people are using row. And then once you've chosen the object that you want to go away and spawn, you can then choose how you want to affect those objects which are getting created. So in this particular case, I'm saying that the index of 0, which is my first column in the CSV file, I'll just quickly show you the CSV file. About as simple as it gets. In the first column, I want to use that for changing the scale of my position by 3. Yeah, so this is now moving these elements across every time it gets to a new row. But I want to take the I'm using that in a stepped mode. So every row is taking the step and then it's adding 3 to it. But on the next, so back up, I just made a quick mistake there. So for the X moving across, I'm stepping. I'm not using the values from the CSV. For the Y, I'm using the CSV data from in the first column, 0, and then I'm multiplying it by a factor of 10. Yeah? So we take 0.5, we multiply it by 10, and we're getting 5 appearing here in Notch. There are a couple of other modes you can use as well, depending upon the type of configuration in the clone you want to use. One important detail is that you can choose to reflect changes to a CSV file on the fly. Yeah. So if you click Reflect Resource Changes, and I go into my CSV file and I hit Save, yeah, it automatically reflects that back into Builder because it's doing an OS level watch on the file and waiting for the event that says that file has changed. This feature only currently works in Builder, but in the next release will work in standalone and blocks as well. Right. Other ways you can use CSV files. You can actually just read the straight value out of the table just by giving the column and row index and use that as a modifier just to pump that value into your node graph. And you can do the same with text as well. And this is really useful for title screens. And if you've got 10 speakers and you're just able to flick your way through the speakers by reading the text out of a CSV file and then dropping it into a text node. OK, so that's CSV Text Tables. At present, we already have a web API that comes into Notch. What happens is that Notch, when it's running in Builder, standalone, or within a block, actually has a little web server that's running in the background, a tiny, tiny, very responsive little web server. And you are able to make calls to that web server to be able to push values into Notch or pull values back out of Notch as well. And not only is there an API, there's a GUI that sits on top of it too. To enable this feature, you go into your project settings, you click the web GUI enabled, and you set the port that you want the web server to listen on. So in this case, I've chosen 8910, which is our standard default port. So if we have a look at this, back to our yacht, and I'm just going to close this up. I'm just going to change my view. Right. So here I'm just going to connect to my local machine on 8910. Right. So what happens with the web interface is that any value that you are exposing, like you do to a media server, automatically gets exposed to the web server as well. Yeah. So they're all addressable straight away. So if I go here into my web GUI, the API has exposed it, and the web GUI is presenting it out to you on the screen. So in this case, I can switch my cameras back and forth. I can change the RPM of the engine. And you can see it's quite responsive for a web API. And we can change the PSI here as well. Yep. So what the GUI is actually doing in the background is it's making a bunch of API calls that you're just not seeing. And these API calls take a format like this. So in the URL, you call HTTP host, then /control, and then the parameters you need are UID, and UID is this unique identifier. This usually has lots of hexadecimal in it, and you don't worry about it. For this, in this particular case, I've overwritten it with normal text, and this is the identifier of that exposed parameter. You put that UID in there, and then you can set the value after it, and that can be a string, an integer, or a float. If you've got the web server, pretty much always just says OK, even if it's not done anything in the background. Yeah, because it runs on a thread, we don't let it actually talk to the main thread instantaneously. So it will just say OK, even if it hasn't worked. If you want to use special characters, then you just use URL escaping, the normal URL escaping method. So like %20, %2D. And if you want to put colors in, then you separate your colors with %2C, which is the escape code for a comma. But this has been a great tool for us for people who have been wanting to get kind of data from the internet in over time. And what I'm going to do quickly now is just show you in PyCharm. I'm just going to do an HTTP push. So what I've got here is a script that is just pushing values into Notch every second, which you're seeing updating on the screen there. In terms of a typical response time, I've got Postman. If you're doing anything on the web, you'll probably have used Postman before. But I'm just calling the API manually here. And you can see I'm getting a response time of like 15 milliseconds, which is pretty quick. It's not ridiculously quick. But the important thing is that it's not interfering with the rendering of Notch because it's running on a separate thread asynchronously. Yeah. OK. Next up is reading the values back. So if we use that URL string we had before and we don't put any parameters on the end of it, you get a response back that looks a little bit like this. It's basically a JSON format of all the exposed values, what their type are, and what their current values are. And this is a good way for you to be able to poll on a website data that is coming out of your Notch block for some reason. There's not that many occasions where you do this, but it is useful to be able to pull that information out. So, as it stands at the moment with the web push mechanism, if you want to get something from the internet, you've had to push that data into your Notch block or standalone. So to be able to pull something from the internet, you've had to write a piece of middleware, maybe Node.js or Python, that grabs the data from the internet, from your web API, maybe your weather API or something like that, pull that back onto a machine locally, and then push that into Notch. And that's been a bit of a pain. You've had to have an extra application and PC running next to Notch to be able to make those types of web calls until now. So in 0.922, we're implementing a JavaScript function called nFetch. And if you're a JavaScript programmer, you will know the command fetch very well, because fetch is the standard JavaScript command for making a web API call externally. And all we've done with Notch is we've literally just copied fetch as it is implemented in most other JavaScript engines, and just put the same syntax into our JavaScript engine as well. So if you have a web programmer within your team, you just say to them, write your fetch call and put an N in front of it, and it's going to go away and work. Yeah. So The advantage of this is that you can now have your notch block call out to the internet directly and grab information from web API sources. So that could be Twitter, Instagram. It could be your own in-house corporate system, which is giving you various metrics. It could be the ticker of what's happening with the FTSE index. It could be any of these different types of data sources. And you can pull that asynchronously back into your project. We support get, post, put, and delete, which means that you can actually start pushing data as well into those web APIs. So maybe you might have something occurring in your graphics that you want to go and push back out to a web server. You can do that with post and put. Not only can you receive the text and the JSON, you can actually download files as well, which is really useful. So if you're doing like an Instagram feed, you can get you use the API to download the JPEG image or PNG and just drop it into a folder, and then you can have that folder being watched, and you can then use that image within your node graph. So that's really useful. You could do the same with a CSV file, download the CSV file online, and do the same thing. Internally within our JavaScript engine, you can receive the text, but we also have a JSON parser. And the JSON parser is very straightforward and allows you to work your way around the JSON very quickly. And it wouldn't be a true HTTP implementation unless we allowed header manipulation. So you can go away and put your authorization tokens and things like that in the HTTP header, which is required for security for a lot of different apps. So. Let me show you how this works in code, because it's just kind of easier to show this in code. Right. So the nfetch function, which I've highlighted there, takes the URL. You can take a request header. So here I'm saying the method is get. But because we're running asynchronously, what we do is when we make the call, we say, when you've got that data back, go and call this function and go and do something with it, yeah? Because web calls take time, and we're not going to be stopping the rendering whilst we're waiting for a web call, yeah? So you say, this is the function that I want to call when I get that data back, and then you can, the next time the next frame starts to process, it will call back this function. So it doesn't run it threaded, it runs it in the main thread, but as soon as that frame starts, it goes, right, while we were waiting, I got that data back, and now you can go ahead and process it. You can check the response, the status code. You can see here the JSON parser, so you just ask for the JSON back, and it will give you a JSON object. You can then start to work your way through the tree. So if I pull, I'll just show you the data we're going to get back from this API, which is a weather API. I'm going to look for main and temp within this JSON. So if we look for, there's main and there's temp at 285 kelvins. So you can very quickly just work your way around the JSON with our JSON parser. And then once you have that data within your JavaScript, you can start pushing it into exposed parameters very quickly into your node graph just with single lines. I'm not going to run through that now. It's all documented on the manual. So let's put this all together. I'll move this up to 3. OK. Here's my little weather dialog. This is in the JavaScript node. In the piece of JavaScript we've got before, I'm receiving in from the node graph a code for the city. Who has traveled the furthest here to be at NotchCon? Where have you come from? Montreal. OK, Brett, Las Vegas. Yeah, OK, I'm going to go culturally further. Maybe Las Vegas, culturally further. Yeah. Where are you from, Mike? LA. OK, I'll take Los Angeles. OK? Clapham, give me a break. You said no heckling. I'm going to count that as heckling. So I actually already have the code for LA here. And what I'm going to do is I'm going to drop this into my node graph for the city. And once I do that, press enter, there we go. What we've done now is we've taken that code. We've actually gone away and called an API. You can see the API call we made here in our log with your city in. And when we've done that, We can see the callback being activated. We've got a 200 back from this weather API. I'm using Open Weather Map. It's a great weather service, and it's free. And from that, we pulled back that it is 12 degrees, quite balmy, with a bit of fog in Los Angeles today, and 0.9 kilometers per hour on the in the wind. So I hope that just gives you a flavor of what you're able to do with the new nfetch functionality. I know I moved through that very quickly. Often when you're calling web interfaces, you want to do things periodically, and we are introducing into the JavaScript engine a timer. So you can say, call this every 3 seconds, yeah, rather than having to do your own timer, which is a bit of a pain at the moment. Good. Right, the last one. For a long time, people have wanted to be able to stream geometry directly into Notch. So they want to use Notch as the renderer, but they have some custom application like a LiDAR scanner or something like that, where they have their own geometry being created, and they want to push that live into Notch. So in 0.922, we're introducing a geometry streaming protocol, which allows you to push that geometry in. So the other applications of it, we've had people who want to do things like surface charts and things like that, and this will enable that. The stream is our own custom proprietary, well, not proprietary, it will be open as a standard that will be documented in the manual, and we're going to be releasing C++ reference files so you can see how to write your own streamer into Notch, and we'll probably release Python ones at the same time as well. So you can see very quickly and have a little library there to push geometry into Notch. It acts as a normal mesh and does all the things that you would expect, and I'm going to give you a quick demo of this now. Right. So it works over the network, and what I've got here is just a little C++ program, a single file C++ program, and I'm setting in this file that I want to send it to my local machine, and I'm going to send it on port 13001. And when I'm within Notch, there is a new node called the Geometry Network Receiver, and in here you set your port, and then when you hit play, and if I actually run the program, right, now we're running. This geometry is being generated by that C++ program and is being streamed across the network and pushed into Notch. The types of data that you're able to stream are vertices, the colors on the verts, the normals, and at present we're saying sub 20,000 polys is probably a reasonable number to be able to push in. That might expand in future. Not only are we allowing you to stream geometry directly and use your own custom apps, we're allowing you to stream geometry out as well and stream between instances of Notch. So there are two, as well as the Geometry Network Receiver node, which I just showed you there is a sender, and you can basically link a sender to a receiver on 2 different Notch blocks, and it'll send that data over the network. If you're doing anything around connect, then this is obviously really useful because you put the connect in on one side, pass it through, and then have it running out on multiple machines on the other side. There's no doubt this is a bit more on the hardcore end of Notch, but it's something that we've needed, especially for third-party developers who wanted to bring things in. So there we have it. Our interface will tour through AV and data, and I've shown you 2 new features which are coming in 0.922. So thank you, and questions?
Your JavaScript fetching from web APIs works asynchronously. So if we imagine we build a scene where we walk along a path, and to the left and the right we have signposts of Instagram images that we fetch from the Instagram API. How to handle the situation when the picture is not available? Is there an option when I say I walk along the path and when there's not a picture ready because it has not been fetched from the API, what to do when the picture is not there? Can I stop it? Can I say I want to fetch it synchronously and keep on rendering, or is it always going to come asynchronously?
We'd only do it synchronously because we don't want anyone screwing with the main render thread. But what you can do when you're making your callback, you would set a flag. So you would say, I'm setting a flag saying I'm going to go off and get that data. Because you can just check for it every frame and go, has that flag been changed? Because in the callback, you change the flag back again. So you maybe set an in-flight request flag to 1 when you start making the callback. And then when the callback comes back, you set it back to 0 again. And then you just use logic every frame to say, is that callback in flight or not? And then do whatever you want on the basis of that with that state. Yep. At the back.
Do you plan to open up the streaming geometry to shared CPU memory or shared GPU texture memory?
No.
Okay. Thank you.
Yeah.
What's the delay on the geometry streaming?
I haven't accurately measured it yet, but I think it's going to be around 3 frames. It uses a lot of the same pathways that I showed in distributed rendering. Yeah. So, and it has exactly the same profile of usage. So it's going to be around 3 frames. Yeah. As soon as you expose it, it's available. Yeah.
Specifically about the web API, is there going to be an option to create columns and groups and make it a little bit more, I don't know, I had one that was just a really, 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 really long list.
Yeah.
It was kind of hard to use. And then I started grouping them and then, is there any way to make it columns just something like that?
There isn't. This has come up a number of times. I think we might revisit this decision, but we basically, in the development cycle, we said, look, we're going to put out an API and an example implementation of the GUI, and then people can go and write their own GUIs. But I don't know if people are actually going to go away and write their own GUIs. Yeah, so we might, yeah, but it's not high on the list. At the moment, the focus is on making open protocols that people can get things in. And then we could probably return back to the GUI maybe at a later time. But you're not the only person. Armin also keeps on hammering us about it internally too.
If anybody makes one, please share.
Yeah.
Could you maybe just export the HTML?
It's built dynamically. So it just receives the JSON and then builds all the HTML elements with JavaScript. Yeah.
Can you hammer the HTTP get requests? With loads of data at the same time?
When you're pushing into Notch? Yeah, you can. But your mileage is going to vary on a lot of different things. The CPU, it's threaded, so it will take a lot, but there are limits.
Is it down to which be a bigger factor, network latency or the processing?
It's the processing.
So if you're sending a message every frame, would that be?
Yeah, message every frame is fine. Yeah, absolutely. Yeah, it's like when you're doing 100 a frame. That's when you start thinking about it.
Can you compile them all into one message?
No, you can't at the moment. Yeah, we may change that in the future. I'm looking at a JSON format that you can push in with like a post request, and then you could do multiple parameters in that. But right now, it's just a GET request to make those changes. Yeah.
In the reflect or the CSV tables, in the second thread that when the computer has problem to access, we don't read the whole launch.
Yeah, I think it might be in a second thread. It's not? Okay, right. Well, yes, is the answer that needs. Yeah. Yep. Anyone else? Good. It's 12:56. Lunch is going to be served in 4 minutes down in the lawn. Thanks very much for your time and coming to the session.